Welcome to Landscape Irrigation Week 8. This week we'll be talking about Rainbird Chapter 8 from the Landscape Design Manual. The topic is on locating the controller and sizing the valve and power lines. Okay, once you've done your design, you need to figure out where the home for the controller is going to be. In this manual, they refer to it as locating the controller, but basically, where are you going to put the controller in this particular system? And in this illustration, you can see that the irrigation controller has been placed inside of the garage, and they're illustrating the wires coming from the controller to each one of the valves. This particular controller in this design is an indoor controller, and it's inside of the garage. Its voltage needs are 120 volts AC coming to the controller. The controller will have a transformer either integrated inside of the controller, or the plug that you plug it into the wall is actually a transformer that takes the voltage down to about 24 volts, which is what the irrigation valves are rated at. These are our control wire options. And this particular one first, this is an 18 gauge multi-conductor wire, which is used mainly for residential use, some very light commercial use for shorter runs and for carrying very minimal loads. And when I say minimal loads, I mean you're irrigating with one valve at a time. Some controllers have the ability to operate with several valves at once, plus a master valve, or one valve at a time, plus a master valve. So when you have 18 gauge wire, it's pretty small. So remember, the larger the number, the smaller the wire. And because this is 7 conductor, what that means is you can operate up to 6 valves with it. So however many conductors it is, you subtract 1 for the common wire, and then all the rest can be for individual valves. I'm pointing towards the white wire for the common wire because that's the industry standard. Other than that, that wire is no different than the rest of them. So this white wire, if you had all 6 valves in one location, you would strip this wire back pretty far so that you can get this white wire out and daisy chain it and share the same common from one valve to the next, where all of the rest of the color wires will go to their own individual valves. This next valve wire is a 12 or 14 gauge single conductor wire, which is normally used for commercial use, and it's better for multiple valves operating at one time, so it would have a larger load being carried through it. Also, it can go for a longer distance. The disadvantage to this wire is that it's usually sold in large spools, so you may have to use the same color for all of your valves or for many of the valves. So it's listed here as 12 or 14 gauge. There are some situations where you need a 12 gauge if you're going to be operating many valves at once, or if it's a very long stretch. This last one is a 14 gauge twisted wire or 2-wire for decoder systems. Decoder systems can be for residential or commercial, but most of them are commonly used with commercial applications. 2-wire systems we'll get into a little bit later in the semester, but for now, 2-wire systems have a little bit additional expense to them. So basically, there's a tipping point where it becomes beneficial to use a 2-wire decoder system over a regular conventional controller, and we'll talk about that a little bit more later. Here are some of the control wire connection options. Up here you see what looks like a regular wire nut, and these particular wire nuts are actually waterproof wire nuts. Inside of them, they look just like a regular wire nut, but they also have a silicone seal inside to keep debris from coming inside and corroding the wires. This is the minimal amount of protection that you would want to offer your irrigation system, and can be used in some temporary situations where you just want to hook things up, make sure that it works, but also have a little bit of protection. This is one way to do it. If you're going to use these on a regular basis, they should be used only for residential, 18 gauge wire, and you might want to follow up with some electrical tape on top of these. but this, like I said, is very minimal. Then you can step up to what's called a dry splice connector. This used to be, in my opinion, one of the better types of wiring devices. And how it works is there's these 3 different components, and you would enter 2 or 3 wires into this body, which it looks kind of like just a sleeve, and into this barrel. You can see in this image right here that there's 3 holes. You would slide the wires through there, you would crimp them together, and then you would take that crimp with the wires in it and shove it inside of this plug and bring the plug inside of this body. So it sounds a little bit confusing, but by the time you're done with it, this piece and this piece have been put inside of this body. So now you've not only crimped the wires together, but you've also encapsulated them inside of a silicone filled plug. So once you've used this type of connection, you don't want to take it apart and try to reuse it, but this is a pretty foolproof way of doing it. In the past few years, this type of connector on the bottom has become more popular. And if you're going to be using a decoder system, which we'll talk about later, this is the required type of wiring connection that you would use. Now, there are several different brands out there that look just alike. They all have this blue container where this wire nut ends up going inside of and clipping it down. But what's unique about this one that is made by Hunter Industries is the wire nut has these wings on it right here. And these wings are shaped just like the capsule here. So after you have wired your wires together, you would slide it down inside of this compartment. And because this wire nut has these wings, there's only one way that it really fits in there. And once you've put it in there, it can't twist back and forth because these wings are holding it in place. And then once you have it put together, you slide the wires off to the sides and close the lid. And this has a lot more of the silicone gel in it and protects the wires to a greater extent. This is a close-up of a wiring diagram detail. So this has a lot going on in this particular image, but it gives you kind of a wider view of what's going on and being able to see the controller, the control wires, and the valves all at one time. It also provides me the opportunity to talk to you about a master valve. So here we have several things going on. This is our main water line coming in, and here we have a master valve, and then we have our 2 irrigation control valves. Over here we have our irrigation controller, which happens to be the Hunter HydroWise smart Wi-Fi controller. And then coming out of that controller are the irrigation wires going to each of these valves. So I'm going to describe this in a little bit of detail, starting with this master valve. So this master valve, notice that it is plumbed in line with the main line, but prior to these other 2 valves, which means the master valve basically is under static water pressure all the time if it is normally closed. If it's normally closed, there's no water pressure on this side of the valve until this valve is actuated, which means it tells the master valve to turn on anytime any valve is told to turn on. So if it's time for this valve to irrigate, this valve will open and so will this one. And then when this valve shuts off and this one turns on, this master valve is still open. And then when either one of these, or when they're all done irrigating for the day, these valves shut off and so does this one, which basically leaves this line with no static water pressure in there. So the advantage of having that master valve in there is if something malfunctioned with either one of these valves and it stayed open or leaked, then this master valve would already shut it off. It wouldn't have the opportunity to continue leaking if you're using this normally closed valve. Now, if you were using this in conjunction with a flow sensor, which would be plumbed in between these two with some space in between, you could wire that up to your controller and it would learn the flow of each of these valves. Then, if either one of these valves ever operated in a way that was outside of its window of accepted flow rates that you've set for it, then it would alert the controller and the controller would shut off the master valve. So in that case, what's happening is the master valve is normally open, which means this valve is open all of the time. And the only time that the master valve would shut off is if one of these valves malfunctioned, told the flow sensor that something's going on, and the flow sensor would say, hey, irrigation controller, let's turn this off so that we don't have any kind of leak going out into the field. So if, for instance, this first valve malfunctioned and somebody came along and kicked one of the sprinkler heads in the middle of the night, and so now when it turns on, it's flowing way too fast, it could shut off this valve and shut off the flow sensor, master valve. And then the other option is it could open back up and just irrigate the second valve and leave this valve off. So it's kind of an extra protection to have the master valve in there to be able to protect the entire system from breaks in the lines, and also if there's a high flow situation, it can put a stop to that. The other thing I would like for you to take a look at is the wiring diagram here. So basically, it's kind of hard to see what's going on here, but you have these two red wires are going to this irrigation controller. Plus you also have a white wire, which is kind of hard to see. It kind of looks like it's a little bit gray. So you have a common wire coming to your master valve, and you also have a control wire. Then this goes back to your controller and is hooked up under the master valve. Sometimes, most of the time it says MV for master valve. Then this valve right here, you can see has this blue wire, and it also has that white wire. So this white wire comes back up here, goes to the common, and then this blue wire would go to station 1. And then over here, this other valve has this green wire, which would be station 2's wire coming back. And it also can share the same common in the same wire nut, even if they're close enough. Or if it was an individual 14 gauge wire, it would go back to the controller all by itself. This is a close-up of what it looks like when an irrigation valve has been wired. So this is the Hunter ICV filter sentry valve, which means that it's made for reclaimed water or less than perfect water. It has a filtering system on the diaphragm. Each time it closes and opens, it scrubs off this filter to try to keep this valve as operable as it can be under the dirty water conditions. So here you have a solenoid with these two red wires, and one wire goes to one of these dry splice connectors, where it is joined with a 14 gauge wire that goes back to the controller. And the other one is a white wire coming from the controller, which indicates that it's the common wire, and it goes to the other solenoid wire. Now, when you're talking about AC solenoids, it doesn't matter which valve wire goes to which one of these wires. It doesn't matter. If this was a DC controller, each one of these wires would be a different color, which would be more important to make sure that you have them wired up the proper way. Okay, so now we're going to talk about 4 steps that Rainbird has lined out in this textbook on determining your size of your valve control wires. So these are the 4 steps. Determine the actual wire run distance in feet from the controller to the first valve on a circuit and between each of the other valves on a multiple valve circuit. 2, calculate the equivalent circuit length for each valve circuit. And from the Rainbird wire sizing chart, we'll select a common and a control wire size for the circuit with the highest equivalent circuit length, or basically the worst case scenario. And 4, having the common wire size established, use the wiring chart to determine the control wire size for each of the remaining valve circuits on the controller. Okay, so step one, we're going to check and see how far away it is to the first valve. And this is figure 74, and it can be found in chapter 8. So the very first valve would be valve number 1 from the controller, and it's going about 2,000 linear feet. So that is our first valve, okay? Our second valve has, our second station on the controller has 2 valves hooked up to it. Now, bear with me that this is not a real common thing to happen, to have 2 valves on the same station, but bear with me because this is the example that we have to work with. So station number 2 has 2 valves. One of those valves has 2,000 feet to travel. The other valve has an additional 1,000 feet to the second valve. Okay, and on the chart that we're going to be using, we're going to be looking at the water pressure at 150 psi. The second step is calculating the equivalent circuit length for each valve circuit. The equivalent circuit length is calculated by multiplying the actual wire run distance to the valve by the number of valves that is located on that circuit. So station 1 only had 1 valve, and it was 2,000 feet away from the controller. So the second one is the one that we need to worry about. The second one will be longer. So station 1 equivalent is 2,000 feet. Now station 2 is a little bit more special because it has this further away one, which is 1,000 feet. And then we also have this run of 2,000 feet. Now remember, like we worked on sizing pipe last week, this is kind of a similar situation where if both of these valves are operating at the same time, it's carrying the load of both of these valves. Well, this valve is 2,000 feet away. This valve is actually 3,000 feet away. So we need to add all of those together. So we have 2 of these valves that go 2,000, plus we have this other additional 1,000, which comes out to 5,000 feet of equivalent circuit length, because we have 2,000 of that plus 2,000 plus 1,000. Okay, so now from the Rainbird wiring sizing chart, we need to select the common and control wire sizes for the circuit with the highest equivalent circuit length. That was the worst case scenario. So looking at this chart below, we'll see that for our 5,000 foot circuit, the length is 6,200 feet. So what we want to do is try to find the smallest wire that we can use to accomplish this. So we look over here and we're looking for 5,000 somewhere in here. These numbers, remember, the bigger they are, the smaller the wire is. So we don't want to bother looking into these larger size wires here. So we're going to come down here and we're looking for the common wire first. So we're looking for the first one on the chart that has 5,000. Well, this one's close with 4,800, but not quite. We need it to go 5,000. So the next closest thing is the 6,200. So what that means is our common wire size meets right here. So our common wire size needs to be 14 gauge. Okay, and so then reading across this left-hand column, we need to find the same thing for that 5,000. And we come down here and we have 4,800, not quite right, and then we have 6,200. So it looks like both of the wires going to the valve, the common and the control wire, both need to be 14 gauge. Sometimes your common might be a little bit bigger size, and then your control wire can be a smaller size. In this particular situation, both wires will be the same size. Now that we've determined the worst case scenario with station 2 and its 5,000 feet of equivalent circuit length, we can move on to all the other valves. And in this case, there's just one more valve. So since we've already determined that we're going to have a 14 gauge common wire, now we need to figure out what size control wire can we use for that first valve. So since we already have a 14 gauge common wire, we're going to scoot over and see what is the first size wire from left to right that meets the requirement of at least 2,000 feet. So the very first one is the smallest wire on here, which is 18 gauge. We come over and we cross it with the common wire and see if it meets that requirement. And it does. It has a maximum run of 3,500 feet. So there's no need to look any further. This particular zone here, Station 1, could use an 18 gauge wire if you wanted to do that. Now it could go a larger one since you already have a spool of 14 gauge wire out there. You can use the larger wire, you just can't use smaller than what the chart specifies. Okay, so the charts that we've been looking at was out of the Rainbird textbook and using the draw from their particular solenoids and the output from their particular controllers. So this particular image is from Hunter Industries, and they have come up with this fairly simple cut and dry chart. So there's not a whole lot of calculating going on, and I'll just run you through it real quick. So here they're saying maximum one-way distance in feet between the controller and their AC valves is if you're using 18 gauge wire for your ground and you're using 18 gauge wire for your common, the furthest you can go is 850 feet. Now, if you were using a 14 gauge wire for your control and a 14 gauge wire for your common, you can run up to 2150 feet. Now, if you needed a larger ground and you went with a 12 gauge ground and a 14 gauge control wire, you can run up to 2,630 feet. So that's another way of doing it. Okay, so another way to look at this, a key takeaway from this is, first, remember that wire sizing, the bigger the number, the smaller the wire. So this first wire, 18 gauge, is pretty small, and then 12 or 14 is a little bit bigger, and then this twisted 2-wire decoder is 14 gauge. So the best thing to remember is that small wire is for residential or very light commercial. And when I say light commercial, I mean like the valves are located right next to the controller and they don't have to go very far. The 12 to 14 gauge wire, the single conductor wire, is normally for commercial use, and you can use that for a longer distance. And then, of course, the decoder wire can run up to several thousand feet. So you have to use some common sense here of how far is your valve going to be from your controller? How often will you actually be more than 100 or a couple hundred feet away? So it might not be necessary to do all of these calculations if you have a very simple cut and dry, one valve at a time system. You may just be able to get away with the 18 gauge wire for all residential and then use 14 or 12 for your larger commercial. Now, sometimes you don't have the luxury of choosing which size wire you're going to be using. You're using whatever has been dictated to you on the irrigation plans. So coming up next in the very last chapter of the textbook, we'll be preparing the final irrigation plan.